In our last session, we discussed about the array implementation of stack and queue. Okay, stack and queue are a list means we can implement the stack and queue using either arrays concept or linked list concept. All the implementations, all the algorithms we implemented using the linked list concept. So suppose we wish to implement it using stack and queue means you can refer the examples given in 6th and 7th session of slides of 6th and 7th day sessions. Okay, here we passed the stack array, queue array, and respective data and the front and rear values to the functions, and we implemented the stack and queue data structures using array. Okay, the array implementation we discussed in our last session, and we discussed one application of a queue, that is categorizing data. One example we discussed. Okay, so this bank example, it illustrates the categorizing application. Okay, so based on the request category, each customer will be served by different queues. So this we discussed in our last class. Okay, so for that I said we will discuss one example program. So here we are going to discuss one example program. What is the example means? We are going to get n number of data from the user, and for based on the data, means based on the number, whether it's odd or even, okay, we are going to store it in different queues. So this program, this queue program, this program is same as the queue program that I already shared with you. Okay, the only I had made changes only in the main function. Rest of everything is same. Okay, see here in main function, I'll show the first queue program also. This is the actual queue program that I already shared. Okay, so in main program, main function, I have created a queue and we are performing enqueue dequeue operations here. Okay, but in this queue application, okay, so categorizing data, so we are going to get numbers in some numbers from the user, and based on that, whether it's odd or even, we are going to store it in two different queues. See here in main, instead of creating a one single queue, I have created two queues. Okay, so odd queue and even queue. Okay, rest of everything is same. Choice, data, count, everything is same. I am creating the queue, odd queue and even queue. Both I am creating. Okay, if any one is fails, then I am raising error called queue creation error. Okay, so the rest of whatever the queue implementation functions, all these functions are same. Okay, I have not duplicated these functions. Okay, these functions are implemented only once. The reference only I am going to pass two different references. The odd queue is one reference and even queue is another reference. So the memory will be allocated and maintained for two different queues. Okay, see here odd queue and even queue. Okay, and I changed the menu. First is input, second is count, third is front, and fourth is rear. Okay, here we are not illustrating any actually useful applications. So we are going to show you how to get input and store it in two different queues. After inserting, what is the count, means how many number of values are there in the first queue and the second queue? What is the front value in the first queue and the second queue? What is the rear value in the first queue and second queue? Just we are going to illustrate that one. Okay, see here in the input, we are getting the input value and checking whether it is a even or odd. Data mod 2, if it is equal to 0 means it's a even queue. So we are inserting enqueuing into even queue the data. Okay, suppose if it is a odd means it will go to else part. In else part, the same enqueue function, but instead of a even queue, we are passing odd queue. So the data will be inserted into the odd queue. Okay, so two queues we are maintaining, enqueue and dequeue. Okay, see here even queue and odd queue. The same way, second functionality is a count, getting the count operation for odd and even queue. Then front, what is the queue front in the odd queue and even queue? We are getting it and displaying it. And the rear value. Okay, we are not performing dequeue operation in this. Okay, so if you wish, you can perform that also. Okay, so now let us run this program and check it. See here, input. I am giving some input values. Okay, 1. So 101 I am giving. Okay, then again input 102, again input 103, again input 104. Okay, and again input 105. Now totally 5 values I have inserted, 101 to 105. Okay, let us check what is the count value. See here, in odd queue there are 3 values are there, 101, 103 and 105. In even queue 2 values are there, that is 102 and 104. Okay, so you can see the count value for two different queues, odd queue and even queue. Now let us check the front value. What will be the front value of odd queue and even queue?
101 and 102.
Correct. 101 is the front value in R queue and 102 is the front value in the even queue. Let us check it. See here, R queue 101 and even queue 102. Okay, the same way 4. Okay, real value is 105 in the R queue and even queue 104. So this is one simple example for categorizing data using queues. Okay, we are getting some sequence numbers and based on whether it is odd or even, we are storing it in different queues, odd queue and even queue. This is one simple example. Like this, we can implement the queue application, categorizing data application. Okay, mostly related to queue applications. Mostly it is not general question to be asked in any exams. So in exams there is chance to ask only the applications of stack. Okay, the infix to postfix conversion or the evaluation of postfix expression. So such kind of questions there is chance to ask. Okay, or illustrate the steps instead of writing the algorithm. They will give an expression and step by step how it will be converted or how it will be evaluated. Illustrate such kind of questions there is chance to ask. Okay, so this is queue application. So this program I'll share it in the Google Classroom. Okay, so in today's session we will start with the complex implementations of a linked list. Okay, now here we are discussing about both circular linked list and doubly linked list. Both we are going to discuss. So what is circular linked list means? Whatever the linked list so far we discussed, it is called as a singly linked list. Okay, what will be the value of a last node? How you can find a last node in a singly linked list?
If the last null.
Correct. The last node's next will be null. So the last node, okay, it will be pointing to the null. The next part of the last node will be null. So using that, we can identify last node in a singly linked list. Okay, what is the circularly linked list means? The last node will be pointing to the first node. So address of the first node will be stored in the last node's next. So it is a circle. Okay, so from any node you can reach and search all other nodes. If it is a singly linked list means, suppose if we are in the middle of the singly linked list, we can perform only the forward search till the end of the list. Suppose again we need to perform the searching from the beginning means, okay, we need to start from the head node and start performing the search. In singly linked list, in circular linked list, since the last node's next contains the head address of the first node, okay, we can continue the search directly to the first node and start continuing the search operation. So this is what circular linked list. Okay, in circular linked list, the last node's link, it will be pointing to the first node of the list. Okay, and here the searching operations may be easy, but the difficulty is, okay, it is difficult to find the last node. Okay, suppose in a singly linked list, we know that to find a last node, it should be pointing to the null. Okay, so that based on that condition, we can perform the searching. Okay, here what we need to do means we need to check whether the last node's next is first node. Okay, based on that, we can check whether we reached the last node or not. Okay, instead of null, we should check the current node's next. Is it pointing to the head node? Okay, if it is so, that is the last node in the linked list. Okay, so this is what circular linked list. Okay, for implementation for circular linked list, we will see it in the next class. Okay, in today's session, we will see the implementation for the next complex implementation. Okay, so the next complex implementation is a doubly linked list. Okay, so here you can find the circular linked list. So we have a header structure. Header structure is having two links. The first head link is pointing to the first node, and a rear link is pointing to the last node. Okay, and see here the last node 95, its link, it is pointing to the first node, that is 5. So it is a circle. From 5 we can go to 10, and 10 to next node, next node, next node, finally 95, and from 95 we can reach 5. Okay, it is a circle. That's why we calling it as a circular linked list. Okay, and the next implementation of next complex implementation is a doubly linked list. Okay, normally in linked list we will have only one pointer which is pointing to the next node in the list. Okay, in doubly linked list, we will have 2 pointers. Okay, one pointer will be pointing to the next node and another pointer will be pointing to the previous node. So what is the advantage here means it is possible to perform the traversal from the first node to last node and also from last node to first node. Forward traverse also possible, backward traverse also possible. So this is what advantage of a doubly linked list. Okay, this is also for searching purpose in searching category. It is very efficient. But the disadvantage is while inserting a data and deleting data, we need to perform some more pointer assignments, okay, compared to the singly linked list. Okay, so insertion and deletion may be little bit complex, but searching is efficient in doubly linked list. Okay, so see here, one example is given here. So here list header, it contains count data and a head pointer, then rear pointer. Okay, head pointer is pointing to the first node, that is 5, and rear pointer is pointing to the last node, that is 95. Okay, here B means the backward pointer and F means the forward pointer. Okay, so 5 is pointing to the 10 and 10 is pointing to next node. Okay, and 95 is the last node. Okay, and 95 is pointing to the 10. Okay, so there is a previous pointer and the 10 is pointing to 5. Okay, so this is what doubly linked list. And the doubly linked list insertion deletion given here. Here they are using the notations B and F. Okay, in our example programs we will use the notations previous and next. Previous means predecessor node, next means successor node. Okay, so let us check. See here, this is what a doubly linked list. The header node. Okay, the header node contains count value. Totally 3 nodes are available, and the head node, it is pointing to the first node, and the L last node is pointing to the last node. 2 pointers we are maintaining in the head data structure. Okay, and the 10's next is 20, and the 20's next is 30, and the 30's previous is 20, 20's previous is 10, and the 10's previous it is null. Okay, and the 30's next is null. Okay, here how we can find the first node and the last node of a doubly linked list means the last node's next will be null. Okay, and the first node's previous will be null. Okay, first node's previous will be null. Based on this, we can identify what is the first node in a doubly linked list and the last node in a doubly linked list. Okay, now how to perform the insert operation in a doubly linked list, that we will see first, then we will go to the program. Okay, now let us take this example. Here I have created a new node. Okay, for a new node, memory is allocated and data for this new node is allocated. Okay, we are going to insert 100. Okay, and we are going to discuss only about insert beginning. Okay, insert in the middle or insert in the ordered list we will discuss later. We are going to discuss only the insert beginning. Okay, now initially for this new node, whatever the data we received as a parameter value that we assigned, and initially its previous and next both will be null. Okay, and in insert beginning we will check whether this is the first node. Suppose if count is 0 means and new nodes, this is the first node in the list means, okay, then its next also will be null and the previous also will be null, and head and list, okay, both will be pointing to 100. Okay, both will be pointing to 100. Okay, suppose if the list already contains some nodes, okay, 10, 20, 30 are there. Now I need to insert 100 as the first node. How many pointer changes I need to do? Okay, what are the pointer changes I need to do means, listen carefully. So insert beginning operation. Okay, the head nodes, whatever the head node is pointing, okay, the 10, its previous must be pointing to the new node. Its previous must be pointing to the new node, and this new node's next must point to the head node, whatever head node is pointing. Head node is pointing 10, so the new node must point to 10. New node must point to 10, and then finally the head must point to the new node. Okay, head must point to the new node. That's it. Insert beginning is over. Okay, let us check the equivalent code. See here. Here the same structure. Okay, so whatever the structure we used in the single linked list, same structure I am using it here. I have added 2 more pointers here. Okay, in data node structure I have added previous pointer, and in the head node structure I have included last pointer. Okay, now insert beginning. See here, insert node. First I am allocating memory. Okay, so first memory is allocated. Okay, memory is allocated. Now it's the data. New node data is whatever the data we are getting as a parameter. So I have assigned 100. Okay, 100 is stored in the new node data. And initially, new nodes previous and new nodes next both are null. So initially, this 100 nodes, okay, it's a previous and the next both are null. After that, we are checking list one head equal to null and a list one last means that list is empty list. If the list is empty list means the last node also must point to null. Okay, the last node also must point to the new node. So this should also point to the new node. If it is the first node, okay, 100 is the first value in the list means both last and head both point to the new node. Okay, suppose if it is not the case, list already contains some 2 or 3 nodes. In such case, the else part will be executed. See here, new nodes next equal to list one head. Okay, so list one's head, whatever it is pointing to 10. So the 10's address must be pointed by the new nodes next. Okay, new nodes next must be the head node. See here, new nodes next must be the head node's address, and then head node's previous. Okay, whatever the head node is pointing, okay, the head node is pointing 10. The 10th previous, it is initially null. So the 10th previous is new node. See here, 10th previous is a new node. Okay, these two cases, whether it is the empty list or list contains some value. Okay, based on that, these 2 pointer allocations will be there. And this is common. Once it is inserted, the list node's head, it should point to the new node. Okay, earlier it is pointing to 10. Now it will be pointing to the new node. See here, list one's head is new node. That's it. Insert beginning is over. As I already told you, okay, we are going to discuss only the insert beginning and delete operations. Okay, insert in the middle or insert in a ordered list. That codes I'll share with you later with explanation. Okay, so this is insert beginning. Okay, suppose if you have any confusions in this, please ask your doubts now. Okay. Okay, now we inserted successfully. Okay, now 100 is the first node, and from 100 we can traverse to 10, and from 10 we can traverse to 20, and 20 we can traverse to 30. Okay, now let us check the display functionals. Then we will come to the delete operation. So display 1, it is printing from the first node to last node. Okay, whatever the node we are inserting in the list last, because it is a insert beginning. Okay, from the first node to last node, printing it. And reverse means we are storing the last node's address. This 30's address in the head node. Okay, so using this, we can access the address of 30, and from here we can traverse to 20, and from here we can traverse to 10, and from here we can traverse to 100. Okay, reverse printing also possible. See here, in display, we are creating a temporary variable walker, and we are storing the address of the head in the walker. And until walker becomes null, we are printing the walker data and walker equal to walker next. Okay, the same function can be converted to print the list in reverse order. Okay, 2 changes we need to make in this line and in this line. Okay, can you tell me what are the changes we need to make?
L1 previous, sir.
Correct. Initialize, not here we need to give previous, and initialization. Okay, walker equal to L1 dot, instead of head, what we need to give?
Last.
Correct, because the last contains the last node's address. So here we need to give walker equal to L1 dot last, and here we need to give walker equal to walker previous. See here, display reverse function, initializing with the last, and walker equal to walker previous. Okay, first we will see the output for insert operation, and then display operation, and then display reverse operation. Then we will come to the delete functionality. Okay, now let us compile this program. Okay, so insert 100, sorry 10, then again insert 20, again insert 30. Okay, totally 3 values I have inserted, and finally I am also then inserting 40. So 4 values I have inserted, 10, 20, 30, and 40. since it is beginning, insert beginning, 40 will be the first element, 30 will be the next element. Okay, whatever the element I am inserting last, that will be in the beginning of the list. So let us display it. Option 2 I am giving. See here. Now 40, 30, 20 and 10. This is display order. Now reverse. See here 10, 20, 30 and 40. Okay. So we traversed from the last node to first node. Here the traversal happened from first node to last node. Okay. So this is what doubly linked list traversals. Okay. Since each node has previous pointer, it is possible to traverse the entire list from last node to first node. Okay. Because of the previous pointer. Okay. Now let us move to the delete operation. Now, reverse DLM3. Okay. Now, suppose I wish to delete 20. First, I need to search 20, whether the 20 exists in the list or not. Okay. Let us try to delete 20 now. Okay. Now, using the for loop, I can search whether 20 exists or not. So I can create a temporary pointer current, and current will be pointing to the current node. So 20 is the current node. 20 is exist in the list. Now I need to start performing the pointer changes. Suppose if 20 is the current nodes, means the current nodes previous. What is current nodes previous? 10. It should point to the 30. Okay. Where is the 30's address available?
Current next.
Correct. Current next. So the current nodes previous nodes next equal to current nodes next. Okay. That is the current nodes 20, its previous node is 10, its next should point to the current nodes next, that is 30. Okay. The same way, the current nodes next node, that is 30. Okay. Its previous, okay, its previous is now pointing to 20. Instead of pointing to 20, it should point to the 10. That is current nodes previous nodes, sorry, current nodes next nodes previous equal to current nodes previous. The current node is pointing to 10 now. Okay. So if you are giving this change, means the 30 will be pointing to 10. Okay. 30 will be pointing to 10. So two changes we are doing. Suppose whatever the element we are searching, if it is in the middle of the list, means only these two changes are sufficient. That is current nodes previous nodes next equal to current nodes next. Okay. And the second change is current nodes next nodes previous equal to current nodes previous. These two changes if you are doing, means okay, 10 will be pointing to 30 and 30 will be pointing to 10. Now you can free the memory allocated for 20. That's it. Memory allocation is, sorry, memory can be freed. Now the list will contain only two elements, 10 and 30. Okay, 10's next is 30 and 30's previous is 10. Over. So this is one scenario, that is deleting an element in the middle of the list. Okay. Suppose if the whatever the element we are deleting, if it is the first node of a list, means what are the changes we need to do? Okay. Now this is our current. This is our current node. Okay. Suppose if 10 is our current node, 10 we need to delete 10, means what we need to do, means we know that it is the first node, so it is pointing to 10. Okay. So what we need to do, means the current nodes next nodes previous. Okay. Current node is 10, its next is 20, and 20 is previous. It should point to null because the 20 is going to be a first node in the list. Okay. So current nodes next nodes previous, it should point to null. Okay. And head should point to 20. Okay. Head equal to current nodes next. Head equal to current nodes next. That's it. Okay. Now current nodes previous nodes, current nodes next nodes previous is a null, and head equal to current nodes next. So it will be pointing to 20. Now this 10 is, we can remove the memory allocated for this 10. So this is the case for beginning of the list. Okay. Suppose if the element what we are deleting, if it is the beginning of the list, this is the case. Okay. The same way, if it is the last node in our list, Okay, if it is the last node in our list, if this is current, this is the current node means, okay, so what we need to do means, okay, so the current node's previous, that is 20, its next should be pointing to null. Okay, current node's previous node's next, it is null, and then the current last node, okay, list last node is the current node's previous. Current node's previous is 20. Okay, current node's list node's last equal to current node's previous. Okay, so the 20 address. Okay, it will be pointed by now list 1. Okay, so this is the third case. Suppose if we have the element what we need to delete, if it is the last node, this is the condition. Okay, suppose if we have only one node in the list, in such case, what are the changes we need to do? We have a doubly linked list, in that only one node is available. Then what are the changes we need to do? What is the initial values of head and L in the initially? If there is no node in the list, then what will be the value for H and L?
Null.
Null.
Correct. Suppose if only one node the list contains, and that also we need to delete means, what we need to do?
Make head and last
That's null.
Correct. Make the H and L as a null and remove the memory allocated for the current node. That's it. These are all the different cases available in delete operation. If you are searching net, okay, there will be different programs available with the different if-else statements. But understand these 4 cases. Okay, if these 4 cases you need to take care. Deleting the first node, deleting the last node, and deleting the middle node. Okay. Now let us check the code for delete operation in the DLL. See here, delete node. Okay, suppose if head equal to null and the last equal to null means the list is empty, so return 0, error condition. Otherwise, we are initializing one temporary pointer current and assigning head pointer to current. So until we find the searched data, okay, until current not equal to null and the current data not equal to target, the data to be deleted. Okay, then we are iterating to current equal to current next. So this while loop is for searching the node. Okay, searching. Okay, and once this while loop is completed, okay, either current value will be null or the current data may contain the target value. Okay, if the element what we are looking for, if it is in the list, the current will be pointing to the particular node. Okay, and first case we are checking. If current not equal to null and the list 1 head and the list 1 last both are equal, what is the meaning? Current is not equal to null and head and last both pointing to the same node. What is the meaning?
Only one element.
only one element.
Correct. It contains only one element. So in such case, see here, head and last we are making to null and memory we are freeing and decrementing the count. Okay. Then the second case, current not equal to null and the current node's previous is equal to null.
First
Okay.
element.
First element, because if any node's previous is null, it is the first node. So if it is the first node, see here, current node's next node's previous. Okay, current node's next node's previous. There is a 10's next node 20. It's previous. That is 20. 20 is previous. Okay, 20 is previous. What we are giving? Null. Okay, then head should point to the current node's next. Okay, so head should point to current node. Current node is 10. Its next is 20. So head should point to the 20. Okay, head should point to 20. So this is the first node deleting. Okay, then this is first node deleting. Then the third case, current node not equal to null and the current node's next is equal to null. It means that it is the last node. If any node's next is a null, it is the last node. In such case, the current node's previous node's next, okay, it is equal to null. That is, current node is 30 means its previous node 20 and 20 is next. Instead of pointing to 30, we need to make it as a null. Okay, current node's previous node 20 and 20 is next, we need to make null. Okay, see here, null. And L1 last, the header nodes. Okay, header nodes should point to the 20. Okay, see here, last is pointing to current node's previous, free current node, and then decrement the count. The last case is the node is in the middle. Okay, in the middle means current node's next node's previous equal to current node's previous. Okay, see here, 20 we need to delete means this is current node. Current node's next node 30. So 30's previous is 10. Okay, 30's previous is 10. Okay, And the same way, 20 is previous node, 10, it's a next, it should point to 30. So current nodes, previous nodes, next equal to current nodes next. So that is what we are doing in these two statements. Okay. So please go through this code. Okay. If you have any doubt, ask now. Okay. Wait for, means take 2 or 3 minutes time. If you have any doubt, post it here. Okay, now let us check the delete operation. Okay, I am exiting from the program. Okay, now again let us run the program. Okay, performing the insert operation. 10, 20, 30, 40, 50. So totally 5 elements I have inserted. Let us perform the display operation. See here, 50, 40, 30, 20, and 10. Reverse 10, 20, 30, 40, and 50. Now let us delete the middle element first. That is 30. Let us delete it. Okay. Now 30. Okay. Value deleted successfully. Then let us display it. See here, 30 deleted. Display reverse. So here also 30 deleted. Okay. Now let us try to give some number which is not in the list. 100 I'm giving. Okay, so this case is not working. I'll check this case. Okay, so meanwhile, let us try to delete the first and last values. So again, I inserted 5 elements. Now let us try to delete the first value 50. Okay, so delete 50. So value deleted successfully. Let us display the data. So 50 deleted, 40, 30, 20, and 10 only displaying. Now let us try to delete last node, that is 10. So value deleted successfully. Okay. Now display. See here, 10 also deleted successfully. Now let us delete all the values. 40 let us delete, deleted successfully. 20 let us delete, deleted successfully. Now list contains only one value, that is 30. Again deleting, 30. 30 also deleted. Now if I am trying to display means list is empty. Okay, and that's it. So delete operation also working. Suppose if the element is not available, so in such case it is not working. So here I need to give return 0. Then it will give. So all the success cases I am returning 1. Okay. Suppose if the search operation failed, I need to return 0. Okay. So that I missed earlier. Let us check that also now once. 10, 20, 30, 40, 50. So now the list contains all the 5 elements. Okay, suppose if I'm trying to delete any value which is not available in the list, I'm giving 100. Okay, again. Okay. itself we can check if current node equal to null, then return 0. Okay, now let us check it. Now I have inserted 5 values. Let us display it: 50, 40, 30, 20, 10. Now let us perform the delete operation and try to delete value which is not in the list. See here, value not deleted. Okay, so after the while loop, I am checking whether if the current node is null. If current node is null means the data not exist in the list. So I am returning 0. Okay, so in remaining case only, the 4 cases are executed in the below else if statement. So this is the doubly linked list program. Okay, so today's video and this example program, so I'll upload it in tomorrow. So before tomorrow's session, tomorrow morning I'll upload it. Okay, if you have any doubt, you can post it now. Search. Okay, see here in queue rear function, what we are passing as a second parameter, a data pointer. Okay, for this what we are passing means in main we created a variable data. So when you are declaring a variable int data, memory is allocated. Okay, it's the address you are passing. Okay, so here you are using ampersand of data, address you are passing, and this address is accessed by this rear. Okay, pointed by that, so pointed by this data. So whatever the value you are storing, that will be directly stored in the memory that we created in main function.
Okay, sir.
Okay, but
Yes, sir.
see this for this create list. Okay, create queue, we are using double pointer. Okay, why means in main function, whether we are creating a variable or we are creating a pointer,
Only pointer, sir.
only pointer we are creating, means the memory is not at all allocated. Okay, if memory allocated, its address you can pass. It is simply a pointer variable. Now what we need to do means we need to create a memory and its address, its address we need to return. Okay, address of a address.
Okay.
See here, it is a pointer variable. Q itself is a pointer variable, and you are passing address of a queue.
Okay, sir.
Understand the difference between this data and this queue. Data is a variable, for this memory is allocated. Okay, so you are using ampersand data. Okay, you are using ampersand data in the DQ operation. But for this structure, queue structure, you have created only the pointer variable. Okay, and the pointer variable's address you are passing. Address of address. That's why here in create list, we are using double pointer. Just one more minute. Suppose if it is very difficult for you to understand, okay, go for this concept. See here in the doubly linked list itself, we have one more function called create list 2. Okay, here we are passing only one pointer. Okay, but whatever the memory created here, okay, this memory we are returning. See here, return L1. So the return type we need to change. Here it is not called by reference. Okay, you are passing a pointer variable, and in that location you are creating a memory, and once the memory is created, its address you are returning. Its address you are returning. Now how to call this create list 2 function means, see here, we need to catch L1. So L1 equal to create list of L1. Okay, here are we using ampersand symbol for this L1? Are we using? No. Okay, because L1 itself is a pointer. So directly we are sending this pointer to the create list 2. Either call by reference or call by value. Okay, this is equal to call by value because you are passing a pointer to pointer.
Okay, sir.
Okay, so in that particular pointer means you are creating a memory location, and its address you are storing in this pointer variable L1. Okay, and once this function's execution is completed, okay, any memory allocated within a function, what will happen to that memory?
Oh,
After
it
the
will get
execution of
destroyed.
function,
Here is okay.
okay, so it should not be destroyed. We need this memory.
Okay, sir.
Okay,
I
so its
understand.
address we need to pass back to the main function. So
Okay.
in the return statement we need to pass, or using the double pointer we need to pass. That's it.
Okay, sir. I understood now. Okay. Thank you, sir.
Suppose if you are checking internet main, one more minute. If you are checking internet means, they will give create list without any parameter. They will declare everything as a global variable.